Okay, complex numbers. 1 is the loneliest number. False imaginaries are, and they don't even exist. Okay, let's talk about that for a second. So the square root of -1 is I. And that means I squared is -1. And the fact that we call it imaginary is probably not the best thing. Okay, imaginary numbers are not really imaginary, okay? They were once thought to be impossible, and so they were called imaginary to make fun of them. But then people researched them more and discovered that they were actually useful and important because they helped fill gaps in mathematics. But the imaginary name has just kind of stuck, especially because we call it I, so it's just kind of stuck. But that's also how the name real numbers came about. Real is not imaginary. Okay, so let's just get into some of these things. Complex numbers is a better way to think about imaginary numbers. It's just a complex number. There's another piece to the number that we have. Okay, there's 2 pieces to this number. And some things that imaginaries do, so like the spectrum analyzer, wow, I'm way struggling. So that's just like the way music plays. Like I used to watch that when I was younger. You don't see it as much anymore. But electricity, that uses imaginary numbers. The Mandelbrot set, this is like a crazy thing. If you've ever looked into fractals, the Mandelbrot set is a fractal. And if you haven't Googled fractals, like go Google fractal and you'll just get lost in like this mesmerization. Find a YouTube video of it. It's way cool. Quadratic equation. There's tons and tons of things that imaginaries are used for. And they're not just imaginary. They're not just fake. Okay, that's one thing I want to get across. They're pretty amazing. Okay, so negative square roots. Let's just break these down. We're just going to simplify these. So the square root of -144 is the same as the square root of -1 times the square root of 144. Well, the square root of -1 is I. Hey, girl, you must be the square root of -1 because you're unreal. Ryan Gosling, what a guy. I square root of 144. Well, 144 square root of that is 12, so that's going to be 12I. Square root of -80, well, that's going to be square root of -1 times square root of 80. -1 is I, so that's I square roots of 80. Then if we break down 80, you get 2 times 2 times 2 times 2 times 5. So that's really 4I square roots of 5. Okay, square root of -36 over 121. Well, that's the same as square root of -1 times the square root of 36 over 121. And anytime you have those fractions, you can just break it up. So take the square root of the top and square root of the bottom. Well, square root of -1 is I, square root of 36 is 6, and square root of 121 is 11. So we can write that as 6I over 11. Cool? Okay, powers of I. So we have our real number line. Then we also have the complex number line. And you could think about, it's kind of like the X and Y plane, but now instead of X and Y, we're thinking of like a real number line and a complex number line. Okay, and so on the real number line, we count out like 1, and if we were to keep going with this would be like 2, 3, 4, -2, -3, -4, and so on. Okay. Now, we also have our complex line, which is going to count in i's. So that would be like I, that would be -I. If we were to keep going, this would be 2I, this would be 3I, 4I, blah, blah, blah. -2I, -3I, -4I. Okay? And so powers of I. Now, so I am in a master's program right now, and I just learned about this. And we go into way deeper, we went really deep with this, but we can think of powers of I as rotation of 90 degrees. Okay, so we have all these powers here, and this, like, it blew my mind seeing all this. So I to the 0 power is 1. And we knew that. We know anything to the 0 power is 1. Okay, now if we rotate that 90 degrees, so I'm going to rotate that up 90 degrees, Well, that means that I to the first power is I. Duh, we knew that, right? Anything to the first power is whatever that is. Well, then if we rotate that another 90 degrees, we're now at -1, so I to the second power is -1. Which, before, we know that the square root of -1 equals I. So if I was to square both of these, well, when you square square root, that just is gone, so I'm left with -I, or -1 equals I squared. Well, that's what I just figured out, but now I'm doing it visually. Okay, well, then I cubed, rotate it 90 degrees, that's going to be -I. I to the fourth is going to be 1. And then I could just keep going, so I to the fifth would be I. I to the sixth would be -1. I to the seventh would be -I, and I to the eighth would be 1. Okay, so if we look at this, and this little chart right here is kind of going backwards. It starts at I, and then it goes like I squared is -1, I cubed is -I to the fourth is 1. I couldn't find a chart that did it the same way I did it, so just realize that this is going backwards. But if there's no remainder, the answer is 1. If there's a remainder of 1, the answer is I. If there's a remainder of 2, the answer is -1. And if there's a remainder of 3, the answer is -I. And that's when you are dividing the exponent by 4. So if we did an example, so say we had like I to the 97th power. And I want to know what that is. Well, I can just do 97 divided by 4. 4 goes into 9 twice. That's 8, 1, 7. 4 goes into 17 4 times, and then that's 16. I have a remainder of 1. Well, so if I have a remainder of 1, the answer to this is just I. Pretty cool. Okay, so let's get into, if I have I to the 11th. Well, if I divide 11 by 4, I get 8 with a remainder of 3, so that's the same thing as I cubed, which I cubed is -I. 6I to the 13th, well, let's do this I to the 13th first. If I divide that by 4, well, 4, 8, 12, I'm just left with 1 over, so it's just going to be 6I. 2I to the 9th to the 5th power. Well, I to the 9th is the same as just I, because if I divide 9 by 4, it goes in twice with 1 left over, so that's 2I to the 5th. And then you have to do 2 to the 5th, I to the 5th. Well, 2 to the 5th is 32. I to the 5th is just the same thing as I. So we have the square root of -9 cubed times 2I to the 6th. Well, the square root of -9 is 3I. So that's going to be 3I cubed times 2I to the 6th. So that's going to be 3 cubed I cubed times 2 to the 6th I to the 6th. Well, that's 27 I cubed times 64 I squared, because I to the 6 is really just the same thing as I squared. And I cubed is -I, and I squared is -1. So that's going to be 1,728 I. Okay, if you multiply those together, negative times negative makes positive. Okay, operations with complex numbers. So let's look again at our real axis and our complex axis. I wish this would say complex. Complex. Okay, so let's graph these. So 6 minus 4i. So if I go over to 6 and I go down 4, that's where that first imaginary or complex number would be. And then I'm going to add -8 plus 6i. So then from that blue point, I'm going to go back 8, and I'm going to go up 6i, and I end up right there. So that point right there, it would be -2 plus 2i. And if we just add these, so 6 minus 8 is -2. -4 plus 6i is 2i. Cool. So you could just add like tip to tell. Now subtraction is really the distance between things. So if you think about like, I don't know, let's do like 7 minus 3. Well, we could find 3 on here. We could find 7 on here. There's 4 numbers between there. So we can always think about that as the distance between. I don't know where that disappeared to. But so if we do negative 3 plus 5i, so let's go back 3 and up 5i. So that's where we're going to start. And if we're doing the distance between, I'm not going to go from that point. I'm just going to do 4 plus 6i. So if we go over to 4 and then plus 6i, there's that second point. Now, we just need to find the distance between them, and we always start at that second point. So from that second point, I'm going to go back 6, and I'm going to, or 7, my bad, 7, and I'm going to go down 1. So then when I subtract those two, that's really the same as negative 7 minus I. And we can do these. I don't expect you to draw this out every single time, but I think it's cool to see. We could just distribute the subtraction sign, and that's negative 4 minus 6i. And then negative 3 minus 4 is negative 7. 5 minus 6 is negative I. Okay, kind of cool. It's just cool to see it visually, I think. Okay, this one, so let's just do these. Let's distribute that and distribute that. So that's 18 plus 12i minus 5i plus 7i squared. Now, anytime you see an I squared, that's the same as negative 1. So that's 18. 12i minus 5i is 7i. 7 times negative 1 would be negative 7. So this is the same as 11 plus 7i. Okay, this one, you can use distribution. You could use the box. I think I'm going to use the box. So 5 plus 3i, 9 minus 8i, that's going to be 45, 27i, negative 40i, and negative 24i squared. Again, anytime you see that I squared, it's the same as negative 1. So that's negative 24 times negative 1, which is positive 24. Combine like terms, and we end up with 69 minus 13i. Cool? Seems easy enough. Okay, division with complex numbers. So when you're doing division, it's a lot like when we were doing it with radicals. We have to rationalize the denominator. We have to get that I out of the denominator. Okay, we don't like it in the denominator. It makes things a little tougher for us. So to do it, I'm just going to multiply by I over I, because that's going to get me an I squared, which will now make that a negative 1. So that's going to be 26i plus 4i squared over 8i squared. Well, I squared is negative 1, so that's 26i plus 4 times negative 1 over 8 times negative 1, which is going to be 26i minus 4 over negative 8, which then, let's just flip-flop that. Well, I need to do this step. So I don't like this negative in the denominator, so I'm going to multiply everything here. What is going on? Wow, struggle, guys. I'm so sorry. Okay, I'm going to multiply everything by negative 1. So if I multiply that top there by negative 1, that's negative 26 plus 4 over 8, 26i. Now, you always want to write these in the form a plus bi. Okay, write that down. A plus bi. So then this is going to be 4 minus 26i over 8. And then we want to simplify this. So 2 goes into all of that. 2 goes into that twice. 2 goes into that 13 times. And 2 goes into that 4 times. So this would be the same as 2 minus 13i over 4. Cool? And then I went through this, blah, blah, 2 minus 13i over 4. Okay, this one. So this is where we have to use the conjugate. So I have to multiply by 2 plus 6i. Okay, it's a lot like radicals. We're just using complex numbers now. So on the bottom, we're going to get 4, negative 12i, 12i, and negative 36i squared. Well, those 12i's are going to cancel. Negative 36 times negative 1 is positive 36. So the bottom actually equals 40. Okay, and you can always get that by taking this term and squaring it, and this term and squaring it, and adding it together. So 2 squared plus 6 squared. Well, that's going to be 4 plus 36, 40. Cool. So then I squared is negative 1, so that's going to be 2i minus 6 over 40. And then they can all be divided by 2, and I just switched the order of them. So that's negative 3 plus I over 20. Cool? Cool beans. Okay, let's do these real quick. So operations with radicals. Remember, I always simplify this first. So I'm going to just pull out those i's first. Okay, it's very important that you simplify it first. Now, I times I is I squared. 15 times 5 is 75. So I squared is negative 1. And then the square root of 75, we can break that down to 5 square roots of 3. So this is the same as negative 5 square roots of 3. Make sure you simplify the radicals first. Pull out the i's. So this one, 2 square roots of negative 10 times negative 3 squared to negative 2. So that's the same thing as 2i squared to 10 times negative 3i squared to 2, which is going to be negative 6i squared squared to 20, which is going to be 6 square roots of 20 because I squared is negative 1 times the negative is a positive. Break down that 20, pull out the 2, so that's the same as 12 square roots of 5. Okay. This one, again, let's simplify it. So that's the same as I square roots of 2, and then 5i square roots of 6, and the square root of 18. We could break down that 18 if we wanted to. I don't think I did. The biggest thing is to pull out i's. So then we multiply that in, you get 5i squared square root of 20, and then I squared to 36. Well, 5i squared, that's going to be negative 5 square root of 12. I think I said 20 before, I meant 12. And then square root of 36 is 6. And then we can break down that 12. And so that's negative 10 square root of 3 plus 6i. Okay, last one, I think. So again, let's pull out those i's. So this is the same as 3 minus I squared to 3, negative 8 plus 2i squared to 3. Use the box, you get negative 24, 8i squared to 3, 6i squared to 3, negative 2i squared squared to 9. Well, I squared is negative 1, square root of 9 is 3, so that's the same thing as 6. So I get negative 18 plus 14i square roots of 3. Finito. Okay? Pretty cool. Hope you enjoyed it. Bye.